kategori berikutnya yaitu adalah Student Net Zero Healthy Building Design yang akan dibawakan oleh tim Jowata yang terdiri dari Safira Ramadhani, Muhammad Wahyu Saiful, dan juga M. Isa Sakif. Time and place is yours, brother and sister. Here we go.
Good afternoon, honorable judges, fellow participants, and GBC Idea Committee. Let me introduce myself. My name is Shafira Ramadhani Busono. I am an architecture student from Bandung Institute of Technology with my partner,
Isa.
And Wahyu.
and we are here to present Jowata, our net zero healthy building design. Next. So here are some simulation software that we use to validate our proposed concept. Next.
All right, so ladies and gentlemen, let's start with microclimate and site analysis. Next, please. We use several software to find this kind of data. The first one is Climate Consultant, and the second one is the solar charts. And we found that in the site of Jowata, we have several months that really comfort. Let's start in May and then to the October. We do several data just like a temperature and then wet bulb, dry bulb, and also the humidity itself.
Next slide, please.
Next slide. Oh yeah.
Next again.
Next again. Sorry. Next, please. All right.
Okay, so after analyzing the site, we chose to prioritize our anchor of the site towards the east and the west of the site itself. Because the east side, they have many great views like Lake Saguling, golf courts, and mountain ranges. And towards the west of the site, we chose to put some entrance point for the local sellers there. Next slide.
Next. Exploring the greenery of integrated new city, Kota Baru Parahyangan, our site is surrounded by potential range of mountain. Two words that immediately pop out of our mind is Hijau, which is green, and Perwata, which is mountain, in Sundanese. These words become the pioneer for us to create a concept of green terracing, a form of harmonization hilly context of Bukit Parahyangan. We also adapt luhur handap, which is a placement of usage area based on its hierarchy. Next. Starting off with the block geometry adapted from spatial organization, we develop massing with wind flow and sun orientation consideration, reaching most efficient final massing to tackle off sun glare from east direction, but capitalize potential view and allow wind flow penetration. Next. The first one is Ambu Luhur. It is dedicated for private area. Next. The semi-public is called Ambu Tengah. Next. And the public one is Ambu Handap, dedicated for leisure and hub center. Next. We also have visualization of the master plan and connectivity diagram, which we have permeable access, unifying anchor, communal space, and also green connectivity. Next. We also have 3 different unit types that aim for the diverse targeted users and various facilities. Next. The 3 main issues that we develop inside are social, ecology, and economy, in which we hope that Jowata can build smart, sustainable green ecosystem that empowers local community to drive the economy of Kota Baru Parahyangan. Next. Next. So here are some visualization of Jowata. Next.
So now we're moving on to the passive design strategy. Next. So before we dive in deeper towards the optimization, first we try to model out our base building into Revit, and then also analyze it using Autodesk Insight, and then use it as a benchmark on which our design would be improved upon. Next. Okay, so here are the list of suggestions on strategies that could be applied on our design to help improve the EUI. Next. And then these are the five strategies that we chose to use to tackle this issue. First is daylighting strategy, and then next is a ventilation strategy. The third one is adaptive material strategy, and then the fourth one is water efficiency strategy, and the fifth one is vegetation strategy. Next.
Next. So for the daylighting strategy of the exterior of Jowata, we start off with the goal of obtaining the least solar heat radiation with a modification of orientation, geometry, plan layout, and also shading device facade. Next. So we try to run a solar chat simulation for the 6 massing study that we currently analyze. Next. So the first one is baseline geometry with no orientation, and then baseline geometry, and then the last one is proposed geometry with orientation. From this simulation, we have succeeded to reduce 60% of solar radiation exposure to this building. Next. For this shading device, we propose a combination of double skin diasper bamboo and various vegetation facade which is abundant near Kota Baru Parahyangan. After simulation, we succeed to reduce the solar heat gain by 30% by this proposed double skin facade. Next. So here are some the visualization of the facade itself.
Next. Okay, so for the interior daylighting strategy, okay, so we use some different components on our design, which is highlight, AGC high performance window, double skin facade, light shelf, reflective paint and material, green roofs, light duct, and triple pane insulated glazing window. Next. And after that, we do a simulation using Dialux Evo. And the goal here is to provide each unit with sufficient enough daylighting to trigger the circadian rhythm, which is triggered at more than 500 lux without overly heating the interior space. And then these are the 3 variants that we use to simulate. And we chose the last variant, which is the optimized orientation and shading one. Next. So here we could see that after choosing the third one, we still get the more than 300 lux on the first side from the window area. And then this is already enough for a day-to-day activity. And then moving to the balcony, we could achieve more than 3,000 lux, which is enough to trigger the circadian rhythm. Next. Moving on next. So for the natural ventilation strategy, we use green roofs, stack effect, cross ventilation, pollutants absorbent facade, air cleaner on heated air duct, and also valve on ventilation grill. Next. And we achieve this by optimizing our typical plan towards the natural ventilation. As we can see here, the plan is flowed by air freely. Next. And to prove that, we also run a simulation using Autodesk CFD. Next. And then this is the section of a unit on our tower. So we can see here that the air velocity inside each unit is kept below 0.5 meters per second, with an exception on the ventilation opening. This shows how healthy supplies of clean air is being recirculated throughout the unit. Next. And then this is the plan layout of Jowata. We can see here that the cross ventilation that we mentioned earlier and also the stacking effect, both are working properly. Next. Moving into the adaptive material. Next. So here we chose to use locally sourced materials and also high performance materials to help our design. And then as we can see here, there are insulated roof slab, thick wood CLT as the main structure, treated bamboo split as the facade, insulated GRC wall, woven bamboo as the insulation on the podium, padalarang stonework cladding, and also treated full column bamboo, which came from the species Dendrocalamus asper. Next. And to the active design strategy. Next. We chose to implement 4 different strategies like lighting, ventilation, IoT, and water efficiency. Next.
Okay, so moving on to the healthy aspect. Next. So we try to implement healthy aspect of Jowata, referring to the healthy framework by Green Building Council. Here, we propose a biophilic design concept. Next. In which this biophilic design concept can support for healthier Jowata, respecting mind-body system as indicators of health and well-being. Next. For the protect health aspect, to reach the goal, we implement two strategies. The first one is passive, the second one is active, which is happening by the optimization of natural ventilation, pollutants absorbent micropores facade, vegetation strategy, and water retention pool. For active, we implement HEPA filter inside the room, dedicated outdoor air system, indoor humidifier, and also gray water recycle. Next. To reach the goal of prioritized comfort, we try to create a biophilic park. This will maximize the balcony view and also optimizing natural ventilation, create insulation on wall to avoid noises. Next. To reach the goal of harmony with nature, we try to map the green connectivity on our site by creating vegetation cluster as the recreation for outdoor and also vegetation pool facade for indoor area to ensure access for nature from inside. Next. To reach the goal of facilitating healthy behavior, we implement bicycle track, infinity pool, and yoga spot to promote healthy lifestyle for the residents. Next. We also implement the green communal space, amphitheater, UMKM center for empowering the Jowata community and drive the economy of Kota Baru Parahyangan. Next. Last but not least, we also support the take climate action aspect by providing the solar EV charging station and also use low carbon material as the construction of Jowata. Next.
And then for the application of vegetation landscaping, next. So here we could see the different vegetation types which are zoned depending on their uses on our site. Next. And then moving on to the thermal comfort, next. So after running a simulation using the PMV method, we found out that our design complies with ASHRAE 55-2020 standard by just using passive cooling and natural ventilation without using any HVAC. Next.
So, ladies and gentlemen, here's the alternative calculation from Jowata. It's really good because it's below 45 watt per meter square. Next, please. And after that, we also, this is the calculation or comparison between our benchmark and also the Jowata itself. It means that we have a better AUI with the 46 of the less energy intensive, with also Jowata already has a change to save every year in almost 5 million of dollar itself. And we use it with Homer and also Refit and also Autodex inside. Next, please. So here's renewable energy, because one of the pillars for the net zero building is renewable energy, and Jowata use hybrid system. It means we also utilize the solar panel, wind turbine, also pico hydro, and also we need energy storage to store our energy itself. And the daily load of peak is almost, it means 5,000 kilowatt hours. Next, please. Sorry. So here's, I will very quick for this one. So this is our simulation in Homer, and we found the renewable energy offset of Jowata is 71.5%, and with numbers of carbon offset itself. Next, please. And in detail, here's the solar panel installation, and also we already make it a kind of simulation, and 61% of the energy it's come from solar panel. Next again. And here's the detail of wind turbine. We use Sophonis turbine vertical axis for a low speed of wind turbine. Next, please. And we also run the CFD, of course. And here's the pico hydro turbine. We utilize the gray water, and we put it at the bottom of the gray water system. Next, please. And it could cover 3% of our energy utility. And here's the detail of our supporting tools to renewable energy. Next, please. Okay, and this is the waste management. It means it's integrated waste management. And next again. It's also the water management. We also use the gray water itself. Next, please. Next, okay. And here's our water calculation. Next again. Next, please. Right, it's a fog system, so we try to harvesting from the air. Next, please. And we try to simulate in MATLAB also.
So this is a video overviewing our apartment. So yeah, this is the public space in front of the tower. And then this is the podium itself, which heavily uses bamboo as its structural material. This is the view from the podium itself. Yeah, this is the plaza that is used for the social interaction. This is the access towards the local settlement. Yeah, this is a view from the unit of our apartment. And this is on the jogging track, if I'm not mistaken. We plant many different species of ethnobotanical trees here. Okay, that's all from us. Thank you. Terima kasih. Hatur nuhun.